What if the most mysterious interstellar visitor of our generation has just shattered into pieces? New observations suggest that 3I-ATLAS, the object that has confused astronomers since the day it was spotted, may have broken apart violently right after its perihelion. Not into 2 pieces, not even into 5, but possibly into 16 separate fragments. If true, this event could rewrite everything we thought we knew about interstellar bodies and raise a far deeper question: what exactly was 3I Atlas made of? When 3I-ATLAS reached its closest point to the Sun on October 29th, scientists expected a normal increase in brightness caused by heat. But instead, telescopes across the world recorded a sudden spike, a sharp, irregular burst of light that didn't match a normal comet outgassing. Its coma didn't brighten smoothly. Instead, it appeared chaotic, almost fractured. Multiple observatories noticed what looked like several reflection points, as if sunlight was bouncing off more than one surface at the same time. At first, researchers blamed imaging artifacts or dust jets. But as data continued to come in, the pattern became clearer. 3I Atlas was no longer behaving like a single object. Its light curves showed repeated peaks, each acting like an independent body. The dust distribution looked more like debris spreading outward than like a single nucleus shedding material, and the sudden increase in brightness fit perfectly with a violent fragmentation event. Astronomers now believe that, during or just after perihelion, internal pressure may have built up inside the object. If 3I-ATLAS contained volatile ices trapped beneath its surface, the intense heat of the Sun could have ignited a runaway reaction, an explosive burst that tore the object apart. This would explain the irregular coma shape, the rapid decline in structure, and the possibility that the nucleus collapsed into many separate pieces. But here's where things become even more intriguing. The analysis suggests up to 16 fragments, but none have been definitively tracked yet. Why? Because interstellar fragments are extremely faint, extremely small, and move unpredictably once the main body disintegrates. It may take days or even weeks for Earth-based telescopes to separate the debris signals clearly enough to confirm the number of pieces. So, when will we know for sure? Astronomers say that as the fragments continue to drift away from each other, each one will begin reflecting sunlight independently. Once their brightness signals diverge enough, telescopes should be able to detect them. The key moment will come when the debris cloud becomes wide enough that individual fragments can be isolated in images. Until then, all we have are the strange light curves and the peculiar coma structure, both consistent with a breakup. The big mystery now is, why did it break apart so violently? One hypothesis is thermal stress. Interstellar objects may contain exotic materials formed in extreme environments around other stars. When those materials encounter the heat of our Sun for the first time, they may expand, crack, or explode. Another theory is rotational instability. If 3I Atlas was spinning faster than expected, the Sun's gravitational pull could have overstressed its structure. Even a tiny imbalance could become catastrophic. Another possibility is structural weakness. Interstellar visitors like 1I, Oumuamua, and 2I Borisov already showed astronomers that these objects are unpredictable, fragile, and unlike anything in our own solar system. If 3I Atlas was loosely held together, a rubble pile object, then the intense forces at perihelion could have ripped it apart with ease. But there is one more theory, the controversial one. Over the last weeks, scientists observed behavior in 3I ATLAS that didn't fully match known comet physics, small deviations in its trajectory, hints of unusual jets, and non-gravitational forces similar to those seen in Oumuamua. These anomalies led some researchers to suggest that 3I Atlas might not be an ordinary comet. A hollow structure, a layered interior, or even an exotic fragment from another star system could behave unpredictably when heated. If its interior contained cavities, pressurized pockets, or separated materials, a collapse or explosion becomes far more likely. This doesn't mean the breakup was artificial. There is no evidence of that. But it does suggest that 3I Atlas may be far more exotic than initially assumed. A fragile interstellar shard, a remnant of an ancient collision near another star. A piece of a planet's crust, or even a fragment of a destroyed icy world drifting for millions of years. If the fragmentation is confirmed, 3I Atlas becomes the most violently disrupted interstellar object ever observed. It would mean interstellar bodies are far more fragile than previously believed. It would force astronomers to rethink how these objects survive long journeys through the interstellar medium, and it could help us understand why both of the interstellar visitors before it, Oumuamua and Borisov, showed behavior that broke our models. For now, scientists wait. The next set of images could confirm the existence of multiple fragments, or reveal that the object has broken so completely that no nucleus remains. Either way, 3I Atlas continues to challenge everything we thought we understood about the material worlds drifting between the stars. Every new observation makes the mystery deeper, stranger, and more compelling. And if this really was a catastrophic breakup, then 3I Atlas's final act may be the most important clue yet to understanding the true nature of interstellar travelers.